Mr. Beliga is recording, and so do a lecture is so that you understand. In fact, you could have read this on your own, but then the whole idea is that someone, an expert, is now explaining it to you, and so you get the opportunity to ask a question and things like that. Apart from the lecture is not necessary. I keep saying it, year after year. I say that people don't need a lecture if it's not about understanding what is being talked about. Are you okay? Of course, attendance is always also kept. Are you okay? Yes, we keep attendance to also make sure that you are listening, because some students don't even listen to what is being talked about. All right, so let's carry on. I think you are following, you are enjoying it. But to whom much is given, much is required. Always remember that. So I'm explaining the thing to you, and you are getting it in. Are you okay? That means that you're going to be asking you about what is being taught. Anyway, let's move on. So the raster and the vector data model can be compared. Look at area A. The area A, look at it in the raster model. In the raster model, you can see that it's lost its shape a little bit. Okay, not just that. Let's look at area C. Area C seems to have been deformed, right? It's now looking like something else. Are you okay? It's not looking like the way it's really supposed to look like. As you can see that the vector model is very precise in representing the shape. Okay, so it's precise representation. So we can almost compare the two systems. All right. Let's look at which one again is interesting. C has also, so it's really about the imprecision, but someone can also tell that it depends the precision with which the raster is representing space, things within your space in the geography, depends on the size of the pixel or the size of the grid cell. Because now if you subdivide these squares on the right hand side in the raster model into smaller squares, the shape of C, area C, will start coming out. And if we subdivide and subdivide, we will not even recognize it that there are squares anymore. Just like watching TV, most of the things we are watching on our digital TV screens are actually squares, but they are so small you can see. And that's why people are now selling 4K and HD and all these 8K TVs are out there. It's all about resolution. And so the challenge with the raster representation is, one of them is resolution. Okay, so I think naturally we have to talk about the two data structures and see how they compare. Are you okay? Is there a need to still talk about? I think let's touch on this quickly. The vector data model provides a precise representation of geographic features. We said that it's efficient when it comes to storage. Is it? Yes. Let's look at how many things we need to store for the raster and for the vector. We need to store for the vector the coordinates at the various vertices, or nodes that define the area. Whilst the raster has to store all the squares that are within the area. So the more squares you have, the better the resolution. So you end up storing more. So anybody who has a lot of images on their computer will agree with me that that's the main thing. If you have a lot of images on your phone, that is what consumes. Are you okay? Or videos, of course, videos are just images. Are you okay? That are animated. The quality of cartographic output is great. What is cartography? Cartography is about maps. So in other words, if you really wanted to represent something on the paper to show people that, okay, this is what is happening in the project area, you realize that the vector will do a better job than the raster. And that's why engineers hardly use raster. But AutoCAD has introduced, raster, and images can be integrated and overlaid in AutoCAD now. Are you okay? Now the quality, so we talk about the functional tools for operation like map, projection, overlay, and analysis are available. So with the vector, most of the things we're talking about in overlay are actually vector. concepts. You can apply them to, raster, or you can, but it gets quite complicated. Discrete features. Okay, so the opposite of discrete is continuous. Are you right? Discrete means if someone is discrete. Let me give you an example. I'm teaching you English now. Someone is discrete, it means they know when to stop. Someone who is just always talking, they are not discrete. It's continuous. Now, so in geography, when we say discrete features, then it means that we're talking about like something like a football park. It's discrete. It starts and ends. But something is continuous. It never, like a forest. Where does it start? Where does it end? It's quite not. It's always like continuing. It's almost ongoing. Are you okay? It doesn't stop. Temperature. Everywhere there's temperature. That's continuous data. Are you okay? Or continuous feature, if you really wanted to say that, or field data. All right. So customer locations are discrete. All right, because the customer is here. He lives here. That's discrete. Right, and we are saying that those things, discrete data is associated with vector. Obviously, continuous data is associated with raster, the raster data model, or the raster data structure. Are you okay? All right, so I think everything here will make sense. Topology is not a relevant concept with tessellated structures. In other words, raster, tessellated means raster in a way. Are you okay? And all the things we talk about, the nodes, the vertices, arcs, lines that are meeting at nodes, are you okay? Contiguity and all those things can never apply in raster data model. It doesn't work. It's a vector concept. Are you okay? So we are saying that we've tagged on resolution as well. Okay. All right. So we are saying that elevation and vegetation types are continuous data that can be used. Are you okay? Let's look at some advantages of the vector data. Advantages of the vector data. Data can be represented at this original resolution and form without generalization. Okay, so when we look at the image up there, come back to this. This is how on the ground things look like. They look like this. When we represent it using the vector data model, we can see that we haven't lost anything. This is exactly how this like we've captured it. The surveyor has gone to the points, several points, okay, of the building and picked the several points of the paved area and picked them as well, exactly as they are. Meanwhile, look at what the raster does. It kind of misses it. When you look on the image, you see these black lines. The black lines represent the original, objects that we are trying to actually model. And you see that the raster has missed a lot. Are you okay? So we are able to represent in the original form. Okay, data can be represented at its original resolution and form without generalization. You don't have to, compromise on
that. Sir,
yes.
Question, sir.
Go for it.
Yeah, I would like to know among this, which of them is more accurate, and which of them is much more used when it comes to data, keeping a data.
Okay, so
yes, sir.
Vector seems to be used a lot, but I think it depends on the application area. For example, if you want to deal with hydrology, okay. In other words, you want to look at how the water flows from one river source to the other, and upstream, downstream kind of analysis. Okay, that in fact, most people only use vector. They will use raster. Okay, the raster data model.
Okay.
Vector, most engineers will use vector for the whole plan for the area. Okay.
Okay.
And so the rest is, unless you do a survey and really find out how many times people have used the raster model and the vector model. But I think the vector has a lot of application areas. Same as the raster. It depends if you don't know what you are doing. If you know what you are doing, you know what you are doing. Yes. So the most accurate one is the vector model. Why? Because you're able to now go to a particular point and then model it as you want it. In other words, if I want to model a tree, I just take my GPS, okay, or total station and I measure the coordinate of the tree. So I take it close to the trees, the tree itself, yeah, not the spread of the tree, but the actual where the tree actually stands. Then I pick the coordinates. Now that is more accurate than just sending the satellite into the sky. It captures the tree, but I only guess the canopy. Are you with me? So you can see here that, okay, where is the tree? It could be down there anywhere under the canopy of the tree. So the most accurate one is the vector. And yet people are arguing that with the development of very, high resolution sensors mounted on satellites as a platform, remote sensing imagery is coming close. A time will come where people won't bother to be using total station if the imagery is that good. That means everything on the ground is already captured with just one shot. I hope it's a bit clear. Mm-hmm. So that's a good question. Yes, that's a good question. It means we are actually following. Graphic outputs. The vector always looks nicer. So most people, most professionals would like to display vector. Vector data looks nicer than raster data. I'm going to show you my Google map. So Google map has two layers. One is vector, the other is raster. So I'll use it. So as I'm switching, this is an application, this is a software, mobile application. Can you all see my screen with my?
Yes, sir.
Yeah, exactly. So here, excuse me, I bought a small piece of land. So I've actually, pinged it on Google. But let's go to where I am now. So you want to know where I am? I'm just going to switch on my GPS. Are you okay? And GPS stands for Global Positioning Systems class. All of you know this.
Yeah.
I have high expectations. Okay. All right. So now when I click on this button, it's taking me straight to where I am, where I'm speaking from right now. In other words, my phone is a receiver and has talked to the satellites in the sky, and they have fixed my location. All right. And so now this is where I am. All right. So Medina, and you know that rolling circle is to the left, blah, 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 blah. Are you okay? Now, everything that you are looking at, it looks so nice, okay? You don't even see anything, we can't even talk about, what do you call it? The environment and how clean it is. We can't talk about it. And that's what the vector data is. It's very good for presentation. Nobody will know what is going on there. They will just think, oh, nice. Oh, you really live in a very nice place. Until I show you the raster. But the raster is a picture. And the picture is really, it captures the reality of what is on the ground. So let me switch on the raster. So this is the raster. Now you can see that I still have the vector overlaid. So now the idea of overlay to, you can see all that is coming play over here. Now you can see where I live. Okay, I'm paying a very high rent for this place. Anyway, my landlord is still in the house. I should keep my voice down. Okay, but basically, you can see that. Yes, exactly. This is the estate. You can see that the roof. Yeah. Okay, that's a church right there. It's not looking that bad, but you and I will agree that if I take you to a slum area, okay, I don't want to. You all know slum areas.
Yeah.
You won't like what you see, and that's the raster for you. Okay, guys, can you hear me?
Yes, sir, we can hear you.
Okay, I think someone called Mr. Kanti called me from AIT. So where was I? Okay, yeah, so exactly. So that is the whole thing. All that I'm talking about, the reality is in the application. Some like Uber. Okay, so the view you are looking at now is a vector. Is vector. Why? Because they are lines. You are seeing roads. Yeah, these roads are actually lines that are connecting. So, for example, this is a T junction. I'm showing this T junction here. It's So there are three lines joining at that junction. And that's how when you use this, you can actually get direction, turn left, turn right, and all that. So topology has been applied. But the beauty of it is that it's been rendered and symbolized. So you don't really see the bare bones. Are you okay? But behind it, it's just a single three lines joining up. You're seeing more lines than you're supposed to see. All right, great. And then the raster is this one. Okay, so the raster now is capturing, the colors. So there are squares in there. So if you want to just find out the square, just keep zooming closer and closer and closer and closer and closer. In fact, this is how far I can go. But if you really zoom closer, you get to see the squares. Are you okay? All right. So that is the whole idea. This has been captured by a sensor. Okay, by a satellite. It's satellite imagery. All right. So basically, we go back to that, and we are saying that the graphic output is usually aesthetically pleasing. What are we saying? What we're really saying is that vector is more beautiful than raster. Okay, but someone also say that no, I don't think so. Then the reason they don't think so is that if the raster, the resolution is good, the raster tends to be nicer. So it depends on the resolution. Accurate graphic location of data is maintained. Most data hard copy maps are in vector form. These are an advantage to the vector data. Are you okay? It's beautiful.
Okay.
Are you okay? Resolution is kept very precise. Allows efficient encoding of topology. Topology relates to vector data map. Please, when we have 10 minutes, alert me because it seems I don't see it over here. Why? So that I know how to go. All right. Disadvantages of the vector are that the location of each vertex needs to be stored explicitly. In other words, if you don't get coordinates, you don't have vector. Simple as that. Now, if you want to do some analysis in vector, you have to convert data into topological structure. If the lines are crossing anyhow, you get a surveyor out there, you go fix anything, you say, now I'm here, I'm going to develop my own Uber app, my own transportation system, it won't work. You have to make sure that the topological structure has been enforced and lines are meeting where they are supposed to meet. Junctions are well done, not having overshoots and underhangs. Are you okay? Now, algorithms for manipulative and analysis functions are complex and may be processing intensive. Okay, anyway, if you've seen the algorithm, then you care. But I'm sure a lot of you are saying that we don't even care. Are you okay? But that is the truth. Yes, continuous data such as elevation cannot be effectively represented in vector form. In other words, if someone says represent the forest with vector, you simply draw one big polygon and say that's your forest, go for it. And be saying, but I know that not all the area is covered with vegetation. So hello, what are you talking about here? Are you okay? So we mean that you haven't effectively represented, the forest, which is supposed to be continuous. But then the raster. So when you go to forestry commission and all that, when you are working in the bush and all that, if you need a raster, when I'm traveling from Accra to Kumasi, I'm likely to switch on my raster or satellite layer, which is actually raster. Why? So then I can see that there's a river here, there's a lake beside me, there's more forest ahead, things like that. Are you okay? So continuous data is not effectively represented. But the thing is with vector data is that there are disadvantages that are actually the advantages for the raster. So if you want to remember quickly, just take any advantage of vector, you can turn it to okay, a disadvantage for the raster and vice versa. Okay. Now we can look at advantages for the raster data too. Okay, what are some advantages? Geographic location of each cell is implied by its location in the cell matrix. So we have a set of contiguous cells. Now, if you don't know the meaning of contiguous, go and check. It's different from continuous. Okay. All right, class, but I want to make sure you are with me in this. So now, if you have a group of cells that have been arranged, rows and columns, you have a matrix. The concept of matrices fits very well with the way that the raster data has been arranged. And we are saying that the location of each cell is implied by its position in the cell matrix. In other words, if I want to know the location of something, all I need to I don't even need, I just need to translate between the coordinates within the cells and then any other coordinate system that I'm into. Meanwhile, for the vector data, we need actual coordinate systems. I need to know at this point what coordinate was recorded at that point. That is how the vector works. But the raster is inherent, is into it. Are you okay? All right. Accordingly, other than in what do you call it? An origin point, example, bottom left corner, no geographic coordinates are stored. You don't have to be. You see, the explicit storage of coordinates in the vector doesn't happen with the raster. With the raster, you only need one, and then we know the rest. Are you okay? All right. So the rest take their way from the corner because it is regular. Remember, the squares are regular. So you know that from every cell is say 1 meter by 1 meter. So by the time I get to the very end, if I have 1,000 squares, then I have 1,000 meters. So the coordinate there is 1,000 by, if you like, 0. So this is like, math. If you were in class, I could put something on the board, but really it doesn't need to be doing that in that detail. Okay. All right. So due to the nature of the data storage technique, data analysis is usually easy to program and create from. This one, it's like, we have to understand that because all the things that we've learned in matrices quickly can be applied in the raster data because we have a cell structure, a cell matrix. You have a cell matrix. And now someone say, okay, find the next neighbor. So if I have cell ij, then my neighbor is ij plus 1. And this is like, am I talking to people who are aspiring to become engineers here? Are you okay? So then my neighbors are actually I plus 1 comma j. I comma j plus 1. I plus 1 comma j. You get that thing? So already I'm beginning to do analysis. And that is why today most applications, photoshopping, and because it's just fun. Someone can take a picture of you, anytime you take a picture, it's able to identify your face. That is how the artificial intelligence identifies, because it's easy to actually program images. So a lot of applications, apps that have been developed, really, this is the reason. Are you okay? Doing a whole of interesting things, and I think our ladies are really enjoying it, isn't it? Taking pictures and looking beautiful, if that word exists. Looking beautiful and you actually, like, and it's okay. It's all right. The inherent nature of raster math, for example, one attribute math, is ideally suited for mathematical modeling and quantitative analysis. Are you okay? All right. So yeah, that is it. I don't want to go any deeper than that. Discrete data, example, forestry stands. Okay, so forestry stands can be looked at as discrete because we can now find the bounds of it. It's accommodated equally well as continuous data. So now let's look at elevation data to be continuous data. The raster data is able to take care of that. Grid cell systems are very compatible. Grid cell systems are, like your camera is an example of a grid cell system. Anytime you're taking a picture, you should know that it's actually dividing things up. The sensor itself has a grid in there, and those grids, those cells within it, are actually recording the radiant energy that is coming to it. All right. I'll finish, and then any question you have can come. So let me just quickly do this. The disadvantage cell size determines the resolution at which the data is represented. Okay. So depending on your cell size, you will never like raster. You will never like satellite images. And of course, you have to pay more for sub-centimeter, resolution satellite imagery. Are you okay? You have to pay a lot. It's especially difficult to artificially represent linear features. If you want to represent real line, don't try raster. Because the real line itself now, what is the thickness? Are you with me? So don't go buy 10 million Ghana cedi, $10 million satellite image or something every month. You are paying, $10,000 for satellite imagery. When you know your project is on things like that, linear features, roads, roads. Yeah, it depends on the stance. You can probably use that and extract the road from it. So you can buy some satellite image for that. But for certain pipelining work, and you're using satellite image, are you okay? Because the resolution at the moment, you're looking at 0.41 of a meter. That's very good. That's high resolution. But then some satellite images are actually very, very coarse in resolution. You can have a 10-meter satellite image. You can't find your house on it. Are you okay? It is especially difficult to adequately represent. We talked about that. Processing of associated attribute data may be cumbersome because obviously you need to visit every cell. So if your computer, before the lecture started, I was having a chat with Henry also Austin, and then he was saying he's using an i7, and even with that and 1 terabyte storage, he thinks it's still not perfect. The system isn't still perfect. And when you run your program, you process a raster data. You're definitely gonna have issues. Yeah. If your computer is not fast enough and you don't have good memory, your RAM is not really good, and you're gonna have issues. So processing of associated attribute data may be cumbersome. If large amounts of data exist, raster maps inherently reflect on one attribute, of course. I'm talking about that. Since most input data is in vector form, data must be undergo. So that one applies to both raster and vector. You may need to take advantage of all the advantages of raster. You need to convert vector into raster. You take all the advantage of all the advantages of raster. You need to convert from vector to raster to vector in either way. Are you okay? All right. So we now have data integrity issues as you actually do that conversion. Are you okay? Generalization comes in. All right. Most output maps from Gradle systems do not conform to high quality cartographic needs. Most output maps, okay, they do not conform because the thing about raster or everything we do in GIS is that at the end of the day, we need to have a map as the final thing that we print out. Okay, because I did an analysis, I found out that, okay, you are traveling to my party, my wedding at the end of the weekend, and I'm giving you an analysis to say that, okay, use this route. What should I give you? I should give you a printout. That printout normally is the map. Are you okay? It's a representation of the reality. Are you okay? And of course, the output of my analysis. And most of the time, when you give raster to people, they may not be able to actually figure out. Are you okay? They may not even like it. But then I think the vector does very well. For most events, you are given, a paper map, which is actually vector, which is actually made up of points, lines, and polygons. Are you okay? So then, of course, we need to add the scale bar and the north arrow for orientation and all that. For most projects, for engineering projects, I don't see you using raster. In fact, far from it, because the resolution may not even help you. 0.41 of a meter, you are in trouble right there, because the accuracy and precision required for your project is actually sub-centimeter, maybe 0.3 of a millimeter. I don't know, it's 0.3 of a millimeter. Yeah, I think we've been on projects where you have to make sure that objects have been placed to the millimeter accuracy, and satellite is out. Satellite images aren't going to help you. Are you okay? All right, unless you probably use a drone with, I don't know, that kind of accuracy that you could get from that. Are you okay? But you need to definitely check. Okay, so guys, this is the end of it. Any questions to this topic? Very simple, general data models. If you don't understand anything, you let me know, and then I'll do well to answer. Let me see how many minutes you have. Yes, we have just
about 8 minutes left.
Yeah, exactly. So really, it's just perfect. We just ended, exactly where we want to just end it. So now, let me know if you have a question on raster data models, vector data models, then if you don't, any issue, we can also look at it in the next few minutes, and we can say
So
goodbye, and we
question,
can
please.
yeah, go for it, please.
Okay. I would like to know in GIS, for instance, I'm on a project and I want to actually pick data of trees along the road and then maybe check the depth, the invent, and then the top level of a drain. What software? What software can be used for that kind of
okay, I think
collecting of data?
yeah, good. Thank you for your submission and contribution. So when you mentioned trees, you've mentioned drains. So
Yeah.
straight away, we are talking about two different objects. Okay.
Yes.
And so you need to tell us what you're actually working on. Of course, when you work on a project, you deal with trees, you deal with drains, you deal with, you know, rivers
Buildings
crossing.
and yes.
Rivers are crossing your project area. You need to deal with that exactly.
Yeah.
So
Yeah.
you also talked about level, top level and embed levels, you know, and all that. I see you're trying to establish a slope, isn't it? And all that.
Yes. Yes.
I don't know if this is outside what we are talking about today. So because we're talking about modeling it, modeling the world, your world. Okay. Normally, on a project like this, you've been given some kind of base map. Okay. You have a base
Okay.
map of what is actually there, and then you designed on top of that. Okay. Now the design can be just planimetric. What I mean is that just a plan. Are you okay? And then you're actually looking at location of trees. Are you okay? You also know where your drains are going. Now, once you introduce your top level and even levels, then we are actually going into elevation here. Are you okay? So changing elevation. Are you okay? All right.
Yes.
So I think you have an object as an engineer to actually figure out what do I want to do. I think every engineer should ask that question, and then you can now find out what do I need. Are you okay? All right.
Okay.
So now you were talking about software. What software can you use? Can you use GIS to determine? Actually, what you really need to know is that you need to deal with data collection separately, and for every project, the data collection has to start, and that's why surveyors always go to the site first. They do all that. They pick a whole lot of levels for you. Are you okay?
Yeah.
Once you have that data, then you can now decide to go into AutoCAD, do a whole lot of things planimetrically. If you want to deal with your slopes, you could convert some of the spot height into, you know, a raster data model. You can do a conversion from spot height to, you know, a raster. I think some GIS software can handle that. AutoCAD can do that. Quantum GIS can do that. If you know, you can just Google it and get a steps. Okay.
Okay.
But then you'll be actually moving from vector to raster. Okay. And then apply. There will be actually tools in the software that allows you to do some analysis in raster. But you need to know what you are doing. Okay. You need to know what am I trying to do? Am I designing or what am I trying to do? Are you okay? So I think you are right that you can use GIS to do some analysis in there. So in the next couple of lectures that will follow, I think we'll concentrate on. I think we'll talk about. In fact, the last lecture we have that won't be too generic. Will be the map projection. So next week we'll talk about map projection. Then maybe our last but one lecture we'll be talking about like something like this. How do we kind of calculate volume using the software and things like that? Are you okay? But I think that's where the interest is supposed to be. That's the focus, not the interest. The focus. costly. So thank you very much for the question.
All right.
Is that Austin or Henry?
This is Julius, sir.
Oh, okay, Julius. Well done. Thanks for the input, Julius. Any more? I think our time is almost. Oh, any more? Any more questions? Are we good? Okay, go for it. Go for it.
So one question.
Julius, is that you again?
Yes, question.
No,
yeah.
please.
Okay, go for it. Go for it. Mm-hmm.
So, how do you use GIS to locate a point?
Actually, you don't use GIS to locate a point. You use GPS to locate a point. And to locate a point is to actually find the coordinate of it. And you store it on a pen drive or you transfer it onto your computer. Is that okay?
Okay. The reason why I'm asking is that...
System. No, you should never say that. How you just to locate a point. Maybe what do you mean? Maybe navigation. Okay. Okay, maybe I think you are coming. Go ahead. Ask me. Go ahead, please. Hello. Are you there, Julius?
Sir, it's not me, sir. It's not Julius, sir.
Now,
I think that should be Henry.
Henry.
I think that should be Henry, yeah.
Henry, are you there?
Yes, sir. Yes, sir.
Your line is bad. Your network is bad. We can't hear you.
Sir, he's not using a good phone, so that is why.
I've told him. In fact, I told him to buy a better phone. I don't know. He's still using this.
Oh, sir.
Yeah. Hey, Harry. Henry. Okay, let's move on. I think Henry wants to know how you locate a point. I think he's talking about navigation. Navigation is through GPS. But GPS works with basic software. In fact, most of the software GPS works with, they are GIS kind of software. So that fishermen can find where the fish are. Have you heard of fishermen using GPS to find where the fish are? Have you heard of that? It's trending.
No, sir.
It's really happening. They are using it. Are you okay? So
but sir, how is that going to locate the fishes at where they are?
Well, the whole idea is that we need to understand how fishing works before we can answer this question. And for me, I think they already know where the fishes are, and then maybe they kind of get a location there.